Hello, everyone. My name is Grigory Trofimov. Welcome to today's session on Bright Talk. The name of the session is Protect Your Legacy When Code Changes Are Needed. Before we get started, I'd like to point out this is part one of a two-part series that we're doing on automated unit testing for legacy code. Part two will be October 13th with Brian McLaughlin. This will be a technical deep dive, a developer session for unit test generation, unit test creation, assisted unit test creation for legacy code. Today's session is focused on project managers, product managers, business owners, app owners, as well as developers. Basically, a more kind of 50,000 foot view of the challenges associated with legacy code and testing it and changing legacy code. So with that in mind, our agenda today, we're going to talk about why do we have legacy code? What is legacy code? How does code become legacy? What's the business impact? And what are the different test strategies that we can apply, that we have to choose from when talking about legacy code? Spoiler alert, we'll take a deep dive into one of those testing strategies, specifically unit testing, the challenges associated with unit testing, the benefits, and how we can simplify that in the long term. We'll talk about code coverage, the value of code coverage. Basically, how do we validate? How do we have confidence in our testing practices in general, not just unit testing? What's the value? Why do we focus on it so much? Why do organizations push for these broad requirements of 60, 70%, etc. And we'll talk about a real life use case where a financial organization had similar challenges, had similar requirements, and what they were able to achieve with the right solution. So with that, let's talk about legacy code. Legacy code can mean a number of different things. I think we all have sort of a general association with the term legacy code, that it's something that we probably don't want to do, or something that we don't want to deal with. And one of the earliest definitions that probably comes from years and years of experience for Michael Feathers, who coined the term legacy code is code without tests. And this is from his book, Working Effectively with Legacy Code, aptly named. In this definition, it's a good definition. It's a definition from someone who clearly has experience working with legacy code. It basically means that without tests, we have a hard time knowing what the code is supposed to do, right? So we can read the code, we can sort of play through it in our heads, what the computer is going to try to do, and when it compiles the code, or when it runs this code. But tests are really there to not only kind of help us understand what it's supposed to do, but also validate that it does the thing that it's supposed to do. So any kind of changes that we make to it, chances are we'll probably have some unexpected behaviors without those regressions. Okay, so this is a good definition, but it's probably not complete. You can also have legacy code with tests, right? Just because there's tests doesn't necessarily mean that they're well written. That can also confuse us. That can also actually put us in a situation where we're having a hard time changing the code. And additionally, just because there are no tests doesn't necessarily mean that it's automatically legacy code. For small code bases, where things are fairly straightforward, you might be okay, right? Another common term that we hear is inherited code. So inherited code essentially means you didn't write this code. Someone else wrote this code, maybe another team, maybe in another decade, right? So you're you're the project owner now of this application that's consists of 2-3 million lines of code, and the team doesn't really have much of uh, visibility into what the intent there was. Now, this code was written again at a different time, maybe with a different set of best practices, right? Maybe it was written before Agile was really really kind of the fundamentally primary way of developing software. Uh, certainly before TDD, right? So when you go back and you kind of look at that code, maybe it was again, maybe it was written without unit tests. Maybe there was kind of a different set of types of tests that were written at the time. But you inherited this code, and you're having second thoughts about how to change it, or even if you have to change it at all. If it works, maybe just want to leave it alone. This is also a good definition, but again, it's not necessarily complete because you don't necessarily have to inherit code for it to become legacy code, right? That it just it it could be, frankly, it could be your own code, right? And maybe you wrote it a while back, and you're looking at it now like, wait, what was this doing? So finally, this is a common definition I saw in actually Stack Overflow and a few other blogs. Is code becomes legacy code when it's written. So basically, all code is legacy code, and you can kind of get into sort of a philosophical conversation here of, well, all technology becomes obsolete as soon as it goes out into production. Kind of same thing with code, right? As soon as it's shipped into production, it becomes legacy code. And really, this comes from the notion that it's just easier to write code than it is to read code, especially if it's not code that either you're familiar with or yeah. I mean, it's again, it's we prefer to write code because right there and then we're kind of thinking about the logic, the design logic of the code itself. But the definition that I think we can all settle on really here is that legacy code in general is code that you're not comfortable changing with. And the key here thing is you, right? So it is a bit of a personal matter of what is your familiarity with that code. The other key thing here is changing, right? So when you have to change the code, when you have to do something with it, whether it's bug fixes, whether it's modernizing it, whether it's refactoring it, whether it's doing some sort of security fixes, the second you're not comfortable changing it, whether it's because there's no tests, whether it's because there is tests but they're poorly written tests, that is essentially legacy code. And a good analogy here is, imagine inheriting a 100-year-old home or mansion from a distant relative, right? It's a beautiful property. There's tons of antique pieces and unique designs in the house. But then once you start looking inside, not everything really makes sense anymore, right? It could be the electrical and the plumbing is outdated or unconventional. Structurally, there may be some questionable decisions that were made over the time. So if you want to fix it, if you want to fix the pool or add a jacuzzi or do something with the stairs, all of a sudden long-term maintenance is starting to look like a very, very difficult task, and no contractor wants to touch it, right? And by the way, these slides here, the images here, if you're not familiar, this is the Winchester home, right? And the story with this house is that she built it because she thought it was haunted, and so the house has all these tricks and all these staircases that go into walls or go doors that go out on the second floor, the third floor, basically to trick the spirits, trick the ghosts into getting lost in the house. Legacy code can be a lot like that, and reading through old legacy code, you kind of start to wonder, okay, what's the idea here? Why why are we in all these kinds of dead ends here from time to time? But legacy code doesn't necessarily always mean bad code. And that's kind of important to consider when you think about, okay, like, how do I test my legacy code? Well, first of all, why do you need to test it, right? Why do you need to change your code? If it ain't broken, right? If it ain't broken, do you need to touch it? And chances are the legacy code itself works, right? This application that you've inherited or that you're looking at now, it's doing the thing that it was supposed to do then. It's doing the thing that it's supposed to do now. So is there a real investment from an organization perspective? Is there a real investment from a product perspective to actually change this code, to actually do something different with it? And that's really the first test of, you know, do we need to spend all this time and effort in terms of testing it, right? Because when you think about it, right, if you have, let's say, 3 million lines of code and you want to write unit tests and you want, let's say 60% code coverage. If you're writing about, if you're writing one line of unit test code for every 10 lines of legacy code, you're still writing 150,000 lines of code at least, right? 200,000 lines of code. And it's only a matter of time until those tests become a fairly large code base and over time also become legacy code, right? So it is a significant investment that you have to acknowledge when trying to decide whether or not to try to obtain 50%, 60% code coverage. The other question that you want to ask yourself is, what is the right test strategy here for this application? If you're looking at an application where breaking down components into logical units wasn't really a priority at the time, you're going to have a hard time writing unit tests for it, right? The unit itself is going to be very loosely defined in that code base. Additionally, maybe you're looking at an application that's really UI framework, right? So maybe UI tests are more applicable in this particular case rather than trying to shoehorn a bunch of unit tests or integration tests, right? There are various ways of testing an application. If we look at a testing pyramid, which we will shortly, the test pyramid suggests that you should be testing your application at all levels of scope, right? And unit tests are fundamentally at the bottom of the test pyramid because we build applications from the ground up. But at this point, we are testing an application from the top down. So, there's an evaluation process there that you should do and kind of decide for your own project, for your own application, what is the right way to test this application. But nevertheless, if you are planning on making changes to your code and if you need to gain a level of confidence that those changes are not breaking the functionality, especially if it's something that was working before, then you do have to test it. You have to test it. You have to be confident that those changes are properly tested before they go out into production. And if you don't, that's going to cost you. That's going to cost you money. There is, there's data, there's statistics, there's research that puts a very precise amount on the cost of fixing structural quality problems in an application. So we have an example here. At the very least, there's kind of the Boy Scout rule, which is leave it better than it was before, right? And this is something that we'll talk about. If you're making changes to legacy code, the changes that you're making have to be tested, right? And if they weren't before, if there aren't unit tests or integration tests, if there are no tests associated with that part of code that you're changing, here's your opportunity to make the code better, make the code more testable. Maybe refactor some classes, maybe pull some logic out into its own logical unit and write a good unit test for it. Incrementally improving on legacy code is a very economical way and a very efficient way of applying quality and adding quality to your legacy application. finally, there's just situations where there's a broad requirement across the board to achieve 60% code coverage for legacy code, 80% code coverage if you want high confidence. I think Google defines these as 60% is acceptable, 75% is commendable, and 90% is exemplary, right? And again, in this case, if you don't have the opportunity to sort of take this and have a personal approach to your project, to your application, and say, well, this is actually what makes sense for us. At the very least, don't try to obsess over getting, going from 90% to 95%, right? At that point, the return of investment on improving code coverage is diminishing. Now, going from 30% to 70% code coverage, that's huge. That means that there's a large chunk of your code base that you are now actually adding tests for, and those tests are running, and they're actually covering a vast majority of application. You're actually commendable, right? In Google's terms. But again, this takes time. Unit test code is code, so you're still spending time on writing that code. And with everything in 2022, anything that we're doing manually, we are looking for ways to automate it. And unit test automation can absolutely help achieve those code coverage goals. So let's talk about unit testing. If we kind of stretch out our DevOps pipeline or our CI/CD pipeline, unit tests take place, right after code analysis, right after static analysis. This is where we run our unit tests now. You might already be doing TDD, which is great, right? So you're writing unit tests before you write, you actually write your code. For legacy code, that's probably not going to apply much in this particular scenario, because that code is already existing. That code is already written. Anything new that you're writing on top of that legacy code, great time to implement TDD, great time to really put good practices in place and maybe avoid new code becoming legacy code in the very near future. Again, if we take a look at the test pyramid, unit tests, they kind of take this fundamental place in the test pyramid. If you look at the folks that sort of coined the test pyramid, like Cohen, Martin Fowler, the idea here is that the lower the scope of your tests, the more tests you're going to have, right? So it's not so much that there's UI tests, there's API tests, there's unit tests. It's you look at the scope of your test, right? And the smaller the test, the smaller the component that it's testing, the more of those types of tests you're going to have. And there's a reason for that. Number one, if you look at this pipeline here, unit tests are at the earliest stages, right? So when we talk about shift left, we talk about identifying defects as early as possible. That's exactly what unit tests are going to help you do. It's also going to help you identify defects in a smaller component of your application, right? So when you have to debug, you have to fix, whatever defects are identified, you're going to have an easier time to do that. Finally, you have an opportunity for faster feedback, right? When you break down your tests into smaller components, you have an opportunity to do things like change-based testing, to isolate various test suites and test cases, and run just those test cases to get faster feedback and validate that whatever changes you introduced aren't breaking your applications. We'll talk about that shortly as well. And of course, unit tests are, it seems that when we talk about code coverage, more often than not, we're talking about unit tests, right? If we're talking to organizations and we're asking, well, how much code coverage do you have today? Usually they're telling us, the code coverage in accordance with their JUnits, right? They're not really measuring code coverage on their manual tests, not really measuring code coverage for UI tests. So unit tests are a predominantly common way of achieving those code coverage numbers, and fundamentally an important part of an effective and efficient and scalable test automation strategy. But unit tests come with their own challenges, right? So Number one, creating meaningful unit tests, and especially when when we talk about automation, which we will shortly, unit tests have to test something, right? You don't just want to call a method and make sure that that method returns something. You're really trying to validate the logic of the unit. You're trying to assert on certain certain variables or values or objects or etc. Right, to ensure that that piece of code, that piece of functionality is doing the thing that it's intended to do, that it was designed to do, or that it had the requirement to do. Achieving code coverage targets, again, we talk about 60%, 80%, if we're talking about 3 million lines of code, or more, that's a lot of code, right? So achieving those code coverage targets, it's not going to be a 1 day or one sprint. Usually, you're looking at months of development work to actually write all those unit tests, because it's legacy code. You're likely starting from a pretty low code coverage number, and therefore a low understanding of what the code is supposed to do. So you're at the same time you're figuring out what the code is doing and how to write good unit tests for it. And so hitting those code coverage numbers, even if you're shooting for acceptable, can be a daunting task. And of course, maintaining unit tests, right? So, if you're looking at 300,000 lines of unit test code, one test is running when you run in one environment, the other, but it's failing in another environment. Okay, how do I debug that? Additionally, if I make changes to my code, do I now have to rerun the complete test suite that might take hours, if not longer, to execute? And when I do refactor code and I do have all that code coverage, what tests are actually affected? What tests do I need to modify, rerun to make sure that whatever changes I made are being validated, right? So the maintenance aspect of that is significant. When I think about these challenges, right, creating meaningful unit tests, achieving code coverage targets, really just kind of boils down to the same thing. It's lots of effort. It's time consuming. It's overwhelming. For legacy applications, writing unit tests and achieving code coverage numbers a lot of times feels like maybe like digging yourself out of a hole that you didn't even necessarily dig, right? And once you've dug yourself out of a hole, you have to also make sure to avoid, digging new holes, right? And that's kind of where the meaningful unit test aspect of it comes in. That's where maintaining unit test suite comes in as well. So here, yeah, we have a metric here, up to 40% overhead to development. We've seen, 40%. We've seen 75%, especially for a team that's dedicated specifically to writing unit tests. And that's kind of a red flag, actually. If you're working with a team and there's absolutely, again, no investment in refactoring the actual code, and teams are writing unit tests, exclusively writing unit tests, and all of a sudden the feedback is, well, this code's not very testable. There's some things here that we should actually be changing, and the direction is, well, we don't want to change the code. We just want to write unit tests for it. That's probably not a good thing, right? At the end of the day, we do write unit tests to ensure that the code is good quality code, and that when we make changes, we're not breaking anything. So 40% is accurate. 25% is something that we see on a typical in a typical development cycle, right? Especially if you're writing new code. And then 75% is something that we see for teams that are exclusively dedicated to writing unit tests for old legacy code. So again, anything that we're doing manually, we're going to try to automate, right? So there are technologies, right? There's AI that we can leverage for creating unit tests. We can inherit some data. We can learn some things about the code by running analysis on the code. We can implement what we've learned from the code and create intelligent unit tests based on various flows, based on what we think the code is supposed to do. Parasoft, we implement this actually at 2 layers. We also implement this in static analysis. So for a similarly daunting task is kind of combing through, your static analysis violations for legacy code. And so being able to cluster, being able to make intelligent decisions about, what to do with those static analysis violations can really save you a lot of time, help you find those actual static analysis violations that you want to prioritize over maybe some of the noise that you might see when you run something like CWE or OWASPs, etc., with some of those lower severity violations. And then again, for JUnit and C and C++, it comes down to being able to analyze the code, and from that analysis to implement some algorithms, some logic in order to create meaningful unit tests and get up to a high code coverage number right out of the box, right? As soon as we run some sort of automation in terms of generating unit tests, we want to see some progress, right? We want to go from 0.5, we want to go to 40, 50%. So how does the autonomous and assisted test creation flow work for unit testing? First is sort of I don't want to say shotgun approach, but essentially first, again, we want to do some kind of bulk creation, right? We want to take all this code that has 0% or 0.5 or 5% code coverage, and we want to take a chunk out of that, and we want to cover as much code as possible with unit tests. And machines can do that pretty well. We have to have some limitation in terms of what we can expect from an automated process like this, but we can expect pretty good results, right? At this point, machines can read code fairly well and generate code fairly well as well, and that's what autonomous test creation is going to do. It's going to get you there quickly, but it's not going to get you all the way, because there are going to be gaps, and there are going to be units of logic that are more difficult to validate, and that they have some inherent business logic that a human does have to provide some level of input. And this is where assisted test creation comes in, because going again from 30% to 70%, or going from 40% to 70%, those are big gains when it comes down to achieving high code coverage numbers and achieving good application quality. So what comes next after autonomous test creation is uncovered code, right? What branches of code are not covered by our automatically generated unit test? This is typically something as a human you kind of have to go through and you kind of have to figure out, right? That's actually more important than the code coverage number itself, is the logical branches, what logical decision making within the code that you need to follow in order to ensure that those conditions are met, that those branches, that those lines of code are also covered. So what an assisted test creation solution will do is it will allow you to see uncovered code, detect uncovered code, and also enable you to clone and mutate existing tests in order to cover those conditions, and actually provide recommendations in terms of, okay, well, here maybe you need to tweak your mock a little bit. Here maybe you need to generate a new mock, or just maybe try a different value, right? Maybe you need to instantiate this variable with different values, and this is going to get you that coverage. This is going to achieve that condition for you. Assertions, right? Without assertions, our tests really don't do anything, right? It's just code that calls other code. So assertions are there to actually validate that those logical units of code are actually doing the thing that they're supposed to do. And again, with assertions, you do want to have that somewhat personal approach. And if we actually go back to our definition of legacy code, right, it's code that you are not comfortable changing, because you are responsible for that code. You are responsible for understanding that code. And so when you look at things like assertions, when you look at getting that extra 10, 20, 15%, and creating meaningful unit tests. Again, that personal approach really comes in. And so your solutions, anything that you're using for automated test creation or assisted test creation, needs to provide feedback, needs to provide recommendations right there and then for you about your legacy code. And these three things, right? The ability to clone and mutate and cover uncovered code, generate mocks where mocks are missing or they need to be tweaked a little bit, and creating meaningful assertions for your unit test. That's going to get you to a fully covered source code. And again, when we say fully covered, we're shooting for exemplary, right? We're shooting for exemplary. Maybe in safety critical, we have to shoot for a little beyond exemplary, but nevertheless, these are the things that will help you get there. Now, you also mentioned that legacy code doesn't necessarily mean that it's code without tests. So you might already have some tests before you embark on this journey of autonomous unit test creation. And when you do have existing tests, a good autonomous solution will actually detect that. And once it generates, the bulk of those unit tests to kind of get us to those code coverage numbers, run some sort of analysis, right? Optimize your test suite. Let's remove some redundancy. Again, machines can do that. Machines are pretty good at being able to detect these types of things and optimize your test suites by removing those redundant tests. This is going to, of course, reduce maintenance in the long run because you don't have the overlap of various different types of tests written from different errors or from different times. Parasoft Jtest. So this is our approach, right? This is what we're doing to help organizations in terms of unit testing. We support JUnit 4, JUnit 5. The unit test assistant takes exactly this approach, right? You have the capability to do bulk creation for your class, for your package, for your project. We're only leveraging open source technologies and libraries, right? So we're not plugging any vendor specific libraries. You can take these JUnits and you can run them externally with Maven, Gradle, etc. However you build your project, however you're running your unit test today. It's a plugin for your IDE for Eclipse and IntelliJ. This is a Java solution. So right there, and then your developers are going to have access to a tool that's going to help them generate unit tests quickly and also have an assisted test creation component that is going to guide them to meaningful unit tests and to meaningful code coverage. The recommendations will also assist with maintenance. Provide your recommendations when you have property changes and things like that might be failing. When there's uncovered code, when there's additional mocks that can and should be generated, and many various other assertion recommendations. So really just kind of a tool right there within your workspace to help you achieve those code coverage numbers. Let's talk about code coverage a little bit, right? So when we're looking at code coverage, specifically at from a unit test perspective, we are missing kind of the big picture, right? That we have other teams in the organization that might be responsible for other types of testing, or it might be the same team, right? It might be the same cross-functional team. So when we look at code coverage and we're just under acceptable, right? Maybe we're at 50% code coverage and we really need to get to 60% or 70%. And we're unit testing our application, but it's just so dang hard to write unit tests for. Well, code coverage comes from other places as well, right? And we can measure code coverage from integration tests. We can measure code coverage from manual tests, from UI tests, and Parasoft solutions enable you to do that. It's called merged correlated coverage. The key thing here, right, is that if you have 60% unit test code coverage, 20% functional coverage, 20% manual coverage, that doesn't necessarily mean that that you have 100% code coverage, right? You're going to have overlap. You expect to have overlap. You expect to touch the same lines of code in higher scope tests than you would with lower scope tests. But this does give you an extra level of analysis that you can perform when you're trying to optimize your test suites, right? If you do have that overlap, and if you're testing certain functionalities of your application at lower levels, does that test still make sense, right? Our UI tests, our functional tests, they take longer to execute, and there is a there's a cost associated with executing and maintaining and developing those tests. So having that complete view of your code coverage for your application can help you optimize your existing quality test practice. Additionally, when you're collecting code coverage, this gives you the ability to do deeper analytics and to associate code coverage with specific tests. And when you do that, and when you're making changes to your application, you're an agile development lifecycle, you're constantly making changes. So understanding how those changes impact the test, what tests those changes are associated with, can help you save time when you're actually running your test suite, right? So modified code coverage is kind of the big result from that. I know on our end, we always focus on modified code coverage in our sprints, because at the end of the day, it's okay, these are the things that we changed. We want to make sure that we have high code coverage. We want to shoot for commendable, if not exemplary, in this particular case, because these are things we're actually making changes to. These are things that we're touching, and they are not the same as they were before. So we have to make sure that we have tests associated with it. But identifying those deltas and identifying those changes and identifying where tests need to be added, where tests need to be rewritten, that could be a challenge if you're not collecting code coverage across the board. So having that visibility will give you access to modified code coverage. Change equals risk, right? So it's important to understand that any changes we make to code base involve some risk. There's risk that we break existing functionality, or that new functionality doesn't work as expected. And the big risk, of course, is releasing code which doesn't work properly. And that can have very real business impact. We know that, that's why we test, right? We also know that often that when code evolves, it gets more complex. There's more interdependencies. Various development teams can kind of become more specialized and fragmented in their scope of knowledge and understanding of the code. And the risk of introducing regressions, even for smaller changes, grows over time. It's critical that as projects get more complex, we maintain a solid foundation of unit tests that development teams can use to find and fix issues as soon as possible, while they are while you're working on them, and really not later on, right? So again, you kind of want that feedback as quickly as possible. One of the challenges, though, is that when the code gets more complex, unit tests get more complex. So test coverage often overlaps in common places, right? If you make changes in a common place, it can be difficult to know which tests to run. It could be difficult to know. It can be difficult to thoroughly verify the behavior in that common code. And if we don't know which tests to run, this can lead to a number of unhealthy scenarios, right? If we don't know, if we don't test our changes enough, because developers are in a hurry, maybe there's a deadline, or they run all the tests in the suite, which can take a lot of time, that takes away from time that we would otherwise spend actually building new functionality, right? So this overlap, you have to mitigate this somehow, right? You have to mitigate this change, and you have to mitigate this risk. Typically, when we make changes to the application like this, and we want to mitigate these risks, and we want to ensure that the core functionality of the application is still intact, we run tests, right? We run them either inside the IDE, which is kind of the pre-check and flow, right? Before we check anything in, we run a common test or a commit suite, right? We use a commit suite to validate those changes, and we also run those tests in CI, which again, might be a separate commit suite, might be the same exact commit suite, right? And this is kind of our way of getting feedback faster and actually ensuring that we have we haven't broken anything. But these commit suite, that can lead to a sort of a false sense of security, right? Because commit suites don't necessarily test the changes that you've implemented. They're really there to validate core functionality, that you didn't really you didn't break anything, but it doesn't actually focus on the code that you've changed. Plus, that commit suite, if you don't have personal, kind of a personal relationship with it, you don't have a kind of, if you didn't define this commit suite on your own, that doesn't really increase your confidence, especially when we're looking at legacy code. So what we really want from a commit suite is we want a smart commit suite. We want a commit suite that is based on changes, and that's where smart test execution and that's where test impact analysis comes in. So based on the code coverage that we have, based on the associations that we have between code and tests, we can detect those changes. We can detect and we can use those changes to say, okay, this is the code that's changed. These are the tests that touch that code. And so what our solutions allow you to do, what good tools should allow you to do is create these smart commit suites that are reflective of the changes that you made to your code, right? And this is what's going to give you confidence that the code that you've modified has tests associated with it, but also the stuff that you really didn't touch, the stuff that is the same as it was, all those tests are intact, right? Those tests don't need to be modified. You actually have this test impact analysis that you're performing to ensure that everything else is fine. We can just leave it as is, but this code that we were refactoring, this code that we're making changes to, we have a full commit suite here that we can run and get feedback quickly, and fix things as they come up. We actually do this ourselves. When we implemented test impact analysis, we went from running something like 4,500 up to 4,500 tests in our builds. And with test impact analysis, we're able to bring that down. It looks like there's a peak of 300, but a good portion of the tests are actually staying, under 150 tests. So you can imagine, we're increasing the velocity of that feedback by 45 times, right? Or up to 45 times. So that's fast feedback. That's great for developers to be able to know that, hey, okay, here, we have some test failures here. Let's go back and fix those real quick before we run the full nightly regression suite. Real use case, financial organization, big bank, does kind of a lot of everything, and has been for quite a long time. The challenge we've outlined here, it's a very common challenge, right? There's a requirement now to achieve acceptable levels of code coverage, and the legacy application of I think it was something like 3.5 million lines of code. They ran code coverage numbers, and they got 0.5% or something like that. So the solution here was to implement Jtest, was to implement automated unit test creation with bulk creation to get those to get that initial code coverage up. This saved them a chunk of time just right out of the box, getting them to close to 50%. But 50%, that's still under acceptable, right? So to get those additional 20 or so percent, this is where the recommendations came in, right? This is where that assisted test creation workflow came in, where recommendations to create additional mocks, to cover uncovered lines of code, to create additional assertions where they needed to be created. The raw numbers here are that this reduced the time spent writing unit tests by 50%. So this is something that came back and they said, number one, these tests are as good as a human wrote them, which is critical, right? Again, we need to write meaningful tests. We don't want to end up with a bunch of legacy unit test code, right? So having an automated process, having an autonomous workflow with an assisted test creation process gives you that. It gives you those unit tests that are as good as a human wrote them. And it's an immediate return on investment. I mean, they were able to shorten the time of the project by 50%, right? And if you're going from a project that had a year or 8 months dedicated to the project, and you're able to do this in 4 months, you're saving a ton of time, right? And the ROI there is immediate. So hopefully this was a very helpful session for project managers. Again, take a look at Jtest if you're looking at a project, looking at a legacy application, and you have this daunting task of achieving high code coverage numbers, and it's code that your team's not familiar with, you're not familiar with, you don't know where to start. Jtest will take you a good portion of the way there, right? I mean, as far as getting to commendable, as far as getting to exemplary, you can do this with the right solutions. Jtest is that solution. Today's session was, again, to kind of help you understand what the flow is, how to think about your legacy code challenges and your code coverage requirements, and hitting those code coverage requirements with unit testing. In a couple of weeks, we are going to have another session with Brian McLaughlin, who will be doing a much more technical deep dive and a technical presentation of Jtest, of actually doing some of these flows like autonomous test creation, assisted test creation, and there'll be a much deeper developer focused session for everyone. So thank you again. Please submit questions if you have any follow-up questions into the question box here. We're going to stick around for another few minutes to answer any questions that are submitted, and hopefully we'll see you in a couple of weeks. So let's see. Let's look at our questions here. Okay, so this is a good question. So what frameworks does Jtest support? So the primary framework for testing Java code is JUnit, and for mocks and stubs and things like that, you're looking at Mockito, right? Spring is also common, right? So we support Spring, we support JUnit, we support Mockito. Again, those are open source technologies that are very commonplace in Java development. We're not adding any proprietary, Parasoft libraries or anything like that into our code. What other languages do you support? So Parasoft, we have solutions for Java code, and that's kind of the main focus of today's presentation. We also support unit test creation for C and C++ code. And for .NET code, we do code coverage. So if you're looking to get that, to get an understanding of what is the, how effective is your test automation strategy, beyond unit testing, with functional testing and manual testing, you want to collect that code coverage, we can do that for your .NET code as well. Does test impact analysis help identify redundant tests that should be removed? Absolutely. So again, when we're looking at redundancies, when we're looking at optimizing our test cases, test impact analysis can do that for you. We actually look at coverage across the board, across all of the tests, and where you have overlap, where you have code that's essentially running the same lines of code. You can actually optimize your test strategy there by running test impact analysis. So again, it looks like we're a little over on time here. So if you do have any other questions, please feel free to navigate to parasoft.com. Feel free to reach out, request a demo. Come join us for our next session in a couple of weeks. We have a unit testing ebook that you can download as well, and there's additional, tons of good knowledge there. Smart folks talk about smart things. So please do navigate to parasoft.com, and we'll see you in the next session.